calcium is critical to maintaining health. It plays a role not only in bone formation, but in muscle contraction and in nerve function as well. In fact, every cell in your body uses calcium. Believe it or not, the 1% of calcium that is not in your bones is the most critical factor in maintaining normal body function. This non-bone calcium comes in two forms. It circulates in the body as free calcium, or it binds to proteins in the blood. About 47% of the calcium in blood is free calcium. The remaining 53% is bound with protein. All of the calcium in the blood serves a useful purpose, but only the free calcium ions exert a direct effect on your muscle and nerve function. For this reason, the concentration of free calcium in your blood is what your body monitors most closely. Calcium cycles between your bones and your blood. It does this with the help of specific bone cells and specific hormones. In the bones, two kinds of bone cells either provide a place to store excess calcium or to release more calcium into the blood. Osteoblasts take up calcium so that new bone matrix can be made. Osteoclasts have the opposite effect. They release bone minerals like calcium into the blood. These hormones are parathyroid hormone, calcitriol, and calcitonin. The hormones work by shuttling free calcium ions among the bones, kidneys, intestines, and blood. Combinations of parathyroid hormone, calcitriol, and calcitonin levels trigger the actions of osteoblasts and osteoclasts. Parathyroid hormone, commonly referred to as PTH, is secreted from the 4 small parathyroid glands embedded in the thyroid gland. Parathyroid hormone is responsible for monitoring any changes in free calcium levels in your blood. When free calcium levels fall, PTH increases calcium concentrations in your blood. It does this by regulating 3 processes. First, PTH stimulates osteoclasts to release calcium into the bloodstream. Second, it signals the kidneys to reabsorb calcium from the blood plasma so you don't lose any through urination. And third, it indirectly increases the absorption of calcium from food in the intestines by stimulating the action of its partner hormone, calcitriol. All of these effects taken together cause an overall increase in blood levels of calcium. When the free calcium reaches normal levels, a negative feedback mechanism shuts off PTH secretion, which in turn causes a shutdown of calcitriol. So, PTH increases calcium concentrations in the blood by acting on bone cells, the small intestines, and the kidneys. Calcitriol is made in the kidneys from vitamin D3 in response to PTH secretion. You get vitamin D3 in 2 ways. Either you get it in your diet or your body makes it in response to exposure to sunlight. Calcitriol, like PTH, helps increase blood calcium levels primarily by increasing calcium absorption in the small intestine. Calcitriol synthesis is also stimulated by prolactin, the hormone that stimulates milk production in lactating women. In other words, calcitriol is a hormone that responds to messages from another hormone, PTH or prolactin, not from calcium levels directly. The milk the woman produces contains a lot of calcium. Breastfeeding is a way to transfer calcium and other nutrients from her body to her infants. Since the mother's nutrients are being passed to the infant, it is important that the mother absorb as much calcium as possible in order to avoid becoming calcium depleted. When free calcium levels in the blood start to fall, the change in levels stimulates the parathyroid gland to secrete PTH, which in turn causes the kidneys to synthesize calcitriol. At the same time, prolactin, a hormone that stimulates milk production, also stimulates calcitriol synthesis, ensuring that the mother gets the maximal absorption of calcium from the diet when she needs it the most. Calcitriol synthesis is actually stimulated by 2 hormones, PTH and prolactin. The third major calcium-regulating hormone is calcitonin. When free calcium levels start to rise, the thyroid gland releases calcitonin, which decreases free calcium levels. Calcitonin stops the osteoclasts from dissolving bone so that no more calcium is released into the blood. In addition, calcitonin stimulates the kidneys to excrete excess calcium in the urine. In other words, calcitonin has the opposite effect that PTH and calcitriol have on the body. It decreases calcium levels in the blood. The interactions of these three hormones prevent concentrations of free calcium from deviating more than 10% from normal levels. However, under certain conditions, calcium levels can move below or above the normal range, creating a calcium imbalance. When free calcium levels fall below the normal range, the condition is called hypocalcemia. Symptoms include confusion, memory loss, and hallucinations. Extremely low calcium levels can result in muscle stiffening and spasms and abnormal heart rhythms. These symptoms can be reversed in most cases if the proper free calcium level is restored. Excess free calcium in the blood is called hypercalcemia. Hypercalcemia symptoms include muscle weakness, lethargy, loss of appetite, vomiting, constipation, and increased urination. Severe hypercalcemia can result in coma and cardiac arrest.